Hello everyone, welcome to a minor video extension of the Programming Strange series. Since I did want to make another video detailing a specific programming skill we did use when making our autonomous and did not cover in the previous autonomous videos. So in this video, we are going to cover lookup tables and taking advantage of regression curves for auto calculation subsystems. So as you can see here, I am in a Google Sheets document, and you can of course use Microsoft Excel if that fits your needs better. But regardless, let's dive in. So first off, what is a lookup table? Well, I'll just make one first. So how a lookup table for FTC usually goes is you have three parameters, and that would be distance in meters. Yes, we're using the standard no, metric system. Um, Angle, hood angle actually. That's just in degrees. You don't really need radians. You can always convert it later. And this one is flywheel speed in meters per second. Typically, it's like velocity, but you get the idea. So typically, how you would actually make the data for a lookup table is first off, if you know a little bit of science, basically your independent variable would be your meters and your dependent variables would be your hood angle and your flywheel speed. So you can change how many intervals of distance you want, but typically a good way to start would be to go by fives. So 5 meters away from the goal, 10 meters away, 15, 20, you get the idea. Right now I'm going to do all the way up to 40. Again, it's recommended that you probably do more because more data is better, right? And so once you've got your distances, now all you have to do to complete your lookup table is to put your robot at those distances. Say, let's begin with distance at 5 meters. Is to position your robot hood and of course your flywheel speed at specific numbers so that at every shot, let's say 9 artifacts in a row, it will hit the goal every single time. Actually, well, most of the time. It's not perfect, but it should be pretty accurate. Now, once you get those numbers, you just plug it in. So let's say, for example, this is going to be completely wrong. We have a hood angle of, let's say, 85 degrees and a flywheel speed of, let's say, 12 meters per second. And then for this one, we go down, so it's like 85, 80, and it's like 11. Again, I'm just pulling these numbers out of nowhere. It's only just for pure illustration. And then flywheel speed could just be 10, maybe like 9.5, 9, 8.75, 8.5, and 8.25. Right. Now that you have all your data points, how are you going to use them? Well, you can always use old trusty dandy Desmos. Now, how do you make a table in Desmos? Well, you literally type in table, Table. And of course, we have three parameters, so you can just add Z1. You can name them anything, it really doesn't matter. So, of course, X1 is going to be the distance. So 5, 10, 15, 20, 30, 25, 30, 35, 40. And then your hood angle are just going to be these values. And in fact, I think you can copy paste them. No, you can't. Hold on. Yeah, you can't. But let me type them in manually. 75, 70, 65, 60, 55. And then for your flywheel speed, we have 12, 11, 10, 9.5, 9, 8.75, 8.5. I did forget 40, 8.25, and this would be 50. Now again, these numbers are absolutely wrong. Do not trust them. Now, if we look over here, would you look at this? Now, these are regression lines. Now, if you don't know any statistics, I'll show you one specific thing you do need to know about regression lines is that you should pay attention to the R-squared value, right? Of course, there's no negative sign. That's just the regular R. You don't need to know that. But basically, R squared is known as your coefficient of determination. Basically, it tells you that how close are your data points to the regression line. So, how much of a fit is the regression line to the data points that you have observed? So in this case, it's just perfect linear relationship. Just for y1, so that would be the hood angle. Of course, because I made it that way, it would be completely wrong. But let's use z1 for example. The point is that you go through each of these regression lines, and you pick the regression line with the highest R-squared value. Again, the max is 1. So you're looking for one that says it's like 0.999. So let's try quadratic. That's pretty close. 0.9947. 0.9985 for cubic. Quartic 0.9988. Yeah. Exponential 0.934. Horrible. Logarithmic. That's pretty good. 0.9949. Parallel. Not so much. Logistic. Also not so much. Sinusoidal also pretty good. But the best bet is going to be quartic. So, how would you implement this regression line? Well, if you go into Android Studio, for example, let's say this is for flywheel velocity. Right now, you can just make some constants, right? Public static doubles, and just input your constants here. In this case, we want quartic, so we need 5 variables. In that case, we do have 5 variables. So we just plug in these numbers. So this number right here for cubic. Don't forget the negative signs. You also should make sure you don't double count whenever you incorporate them into the actual equation you form. And then your last value is about 13.24. Again, it doesn't have to be that specific, but again, it's a double, so no one really throws a fit. Now, since I conveniently already have everything in quartic form, as we can see here, a times math.pow, r is basically distance r, since velocity depends on the parameter input r, which is just distance. And of course, this means to the 4th power, so a4 plus b to the 3rd power plus c to the 2nd power plus d times r plus e. And of course, we have those constants here. And so this is basically it for how you incorporate your regression lines. Of course, this would completely match our parameters because r, since r is distance and distance is our x value, it completely fits. So if your distance is say 2 meters, your flywheel speed would be at about 12.67588 meters per second, right? I do want to warn you that all your values from 0 to 40, they're going to probably work very well. But beyond your data values that you have inputted, let's say like 50 or 60, they're not going to work so well. So I just want to emphasize that all the values that you have made for your distances, that is your most certain That's your most certain result that you should get in terms of your regression line and importing that into your robot that you can ever have. Because if you go beyond these values of 40, you're going into a zone of unknown uncertainty. So yeah, that is basically it for this introductory to regression lines and of course lookup tables. And again, see you all later.